For our first example under cylindrical shell method, let us consider the example mentioned in our introduction about the region enclosed by the x-axis and the parabola y equals 3x minus x squared, which revolves about the vertical line, that is x equals -1, to generate a solid. Now let's find the volume of that solid. Okay, now for our first figure, that's figure 8a. So this is the graph of the function wherein we have y equals 3x minus x squared as the parabola which opens downward, and this parabola passes through the origin, that's 0, 0, and that is also passes through x equals 3, and we have the point of intersection at the x-axis at 3, 0. Okay, so the region is bounded by the parabola and the x-axis, so we are talking about the region, this one, so from the x-axis up to the vertex of the parabola. So that's our region. Okay, from this point, the origin, up to this point at 3, 0. So in our problem, we have the axis of revolution as vertical line, and that is your x equals -1. Okay, so I'll place my rectangular strip here. I use vertical, and as you can see, the strip or the rectangular strip is parallel to the axis of revolution. Okay, so yung difference ng method na to when it comes to the rectangular strip or the rectangular element is that sa this method, ang ating element must be perpendicular to the axis of revolution at dapat naka-attach. Okay, so parang hindi siya possible mangyari dito sa illustration na to. Okay, and then sa ring method or sa washer method, we have to use horizontal strip or horizontal element dito so that the element must be perpendicular to the axis of revolution and not attaching to the axis of revolution. Okay, so as we can see here, there will be two possible solutions. No, so the first possible solution is the one that I am presenting to you, which is the cylindrical shell method, and then the other method will be the ring method, because we can again place the rectangular strip horizontally so that it will be perpendicular to the axis of revolution, and that rectangular strip is not attached to the axis of revolution. Okay, so in this case, let's take a look at the next illustration before the revolution. So this is the graph of the region before the revolution. So ito yung ating region. So tinanggal natin yung graph pababa ng parabola because hindi siya part ng ating region. Okay, simula lang again siya dun sa x-axis hanggang dun sa vertex ng parabola. Kung ang ating solid ay, or kung ang ating region ay magre-revolve about the x equals -1 line, so yung ating region ay magkakaroon ng mirror doon sa kabilang side ng axis of revolution. So this part is the mirror of our region. Okay, so ito yung mag-generate ng solid. And then when the region generate a solid, so ito yung magiging itsura niya in a transparent version. Okay, so kung mapapansin nyo, it's open to below. So meaning, kung titingnan ko siya sa ibabaw, butas siya dun sa ilalim. Okay? Kasi meron tayong space in between the region itself at dun sa mirror ng kanyang region. Okay. So yung ilalim nito, so this is a flat surface because yung ating boundary sa ilalim is a line. And also, if you're going to look at the inside the solid, yung wall ng ating solid is a curve. Okay, so yun yung itsura ng ating solid. And then, kung atin siyang ipipresent ng maayos, so ganito yung kanya magiging itsura. Okay, so the most important illustration under this method is the cross-section of the cylindrical shell. Okay, because dito natin makukuha lahat ng information na kailangan natin para dun sa formula ng volume ng solid using cylindrical shell method. Okay. Now, using this illustration, okay, by the way, bago natin i-identify kung ano yung mga kailangan, atin munang balikan kung ano yung formula ng ating solid under cylindrical shell. Okay, so the volume of the solid is equal to the integral of, we have the constant 2 pi, we have r of x. This r of x is the radius of the shell. The radius of the shell is measured from the element up to the axis of revolution. Then we have the height of the cylinder, and the height of the cylinder is measured from the tip of the rectangle up to the bottom of the rectangle. So that's the upper function minus the lower function, or the upper curve minus the lower curve, or the upper boundary minus the lower boundary. And then we have dx as the thickness of the cylinder. Okay, and then that is evaluated from a as our lower limit and b as our upper limit, or a as the left boundary and b as the right boundary. Okay, so yung volume na to is actually makikita natin siya ulit from the introduction. So yung volume ng cylinder is given by 2 pi times r, where r is the shell radius, h is the height ng shell, and then t is the thickness ng ating shell. Okay, so in terms of x, yun nga ang ating formula ng volume. Okay, so kailangan ko is yung radius, ang kailangan natin is yung height, and then dx is the variable of integration. So let's go back to the cross-section of the cylindrical shell. Okay, unahin muna natin ang height ng ating cylinder. So again, the height of the cylinder is equal to the f of x minus the g of x, or the upper function minus the lower function. Okay, so nasa saan ba yung upper function natin, o yung ating upper boundary? So kung ating titingnan yung ating previous illustration, the upper boundary is at the curve, or at the parabola, which is y equals 3x minus x squared, at ang lower boundary natin is at the x-axis, which is y equals 0. So therefore, the height, or the h of x, is equal to 3x minus x squared minus 0. Okay. Now, for our radius ng shell, so that is the measure from the element to the axis of revolution. Okay. Now, what we have in our illustration are the two parts bago natin makuha yung mismong radius ng shell. So, simula dito sa element hanggang doon sa axis of revolution is your radius ng shell. Okay? So, ang binigay sa atin dito is x plus 1. Saan ba nanggaling yung x plus 1? Okay, so yung x plus 1 yan, you have to remember that the measure or the distance of the element dun sa y-axis if your element is vertical, or if the element is vertical, the measure of this element to the y-axis is always equal to x. Okay, so if this is equal to x and the measure from the y-axis to the axis of revolution is equal to 1 unit, so therefore the measure of the radius is given by x plus 1. So you just add this measure, that's x, from element to y-axis, and then from y-axis to the axis of revolution as 1 unit. So therefore the total distance from the element to the AOR is x plus 1. Okay, now substituting dun sa ating formula, so the volume is equal to 2 pi, that's times the integral of x plus 1. So this x plus 1 is your r of x, that's the radius of the cylinder or the shell, and then the height is given by 3x minus x squared minus 0, or simply 3x minus x squared, then multiplied by x plus 1. Okay, so what about the lower limit and the upper limit? Now again, going back to the illustration, the region is bounded at the left by the y-axis, so that is x equals 0, and it is bounded by at the right by this point of intersection at the x-axis, and that is 3, 0. So your upper limit, or the right boundary, is x equals 3, and your lower limit, or your lower boundary, or left boundary, is x equals 0. So that's why the limit of integration is from 0 to 3. Okay, now let us evaluate the integral. So upon multiplying these two binomials, we have 3x minus 2x squared minus x cubed. And then integrating these terms, we have 3 halves times x squared plus 2/3 times x squared, and then minus 1/4 times x to the 4th multiplied by 2 pi, evaluated from 0 to 3. And then let's substitute the upper limit and the lower limit. So the second term is definitely equal to 0, and then simplifying the first term inside the bracket, so this is equal to 45/4. Okay, so there's a typographical error on this pi, so yung pi dito is not included, and then you multiply it with 2 pi. So the final answer, or the volume of the solid, is equivalent to, or is approximately equal to 45 pi over 2 cubic units. Thank you.